welcome to another episode of FooBar. In today's video, I want to show you a demo of the wait for callback pattern from step functions. I have introduced these patterns in a previous video where I talk about the three different integration patterns that step function has: request and response, the one that you, if you have been using step functions, most probably has tried, the running asynchronous shop that we covered in a previous video, and the wait for callback token, that is the one I want to demonstrate in this video. In that previous video, we introduced everything. I show you some examples, when to use it and things like that. So in this video, we are jumping directly into the code. But let's get started. So this pattern allows you to run a synchronous task. I know the synchronous shop that I show you in a previous pattern also allows us to run this asynchronous task, but in order to use that synchronous shop, that .sync, you have to use one of the integrated services from the functions. So there is a limited list like SageMaker, Bedrock, the functions, CCS, Batch, and a few more. But if you use this wait for callback token, you can integrate to basically anything, any AWS service, or your legacy systems, or some human involved in the process, or whatever. So this is really cool because now you can basically make your state machine wait for something externally to complete. And then when that's completed, you will get the notification that that's done and your state machine can resume. And this is very important when you're working with standard workflows. This integration pattern only works for standard workflows. And in standard workflows, you are only charged for the transitions that you make. So if you put start a new task, like you're waiting, I don't know, for a human interaction that they need to do something in your app, and you put a waiting in your state machine. Basically, every time you wait, you're polling, you're waiting, and those transitions are costing you money. While if you are sending a task token and waiting to get that token back, you are just having your state machine pause, idle, and not costing you anything. So this pattern is really handy. So to get started using this pattern is very simple. In your definition of your state machine, in your task, this applies for task, you need to put after the action. In this case, we are sending a message to SQS. You just put wait for task token. And then you need to send the task token to the next step and persist it and save it. And I will show it in the code how it's done. And then this will pause the workflow, or it will be like waiting, but in an idle way that doesn't cost you any money until the task token is returned. So basically, whatever does the job, and then it returns the task token by calling the AWS SDK, send task successful or send task failure. So we're going to build a simple application now that basically will wait for this task token. It will call some kind of third-party API using SQS. I don't know, it's just a demo. And then this application will put a message into a queue, because that's how we sometimes work with legacy systems, that we put a message in the queue, then the legacy system can take it and move forward. And then this system, in this case, it will be a Lambda function, will do some work in a synchronous manner. And when the work is completed, it will send the result to state machine again. So let's look at the architecture so we know what we are going to build, because maybe you're confused. So we have this state machine that you can see there in pink. And the first step is to send a message to SQS. So this will send a message to the queue, put the message to the queue with the task token, and it will send it to wait for the task token. Then we will have a Lambda function that will do some work, and here we can have anything. This Lambda function is because it's simple, and I love Lambda, but you can do work with whatever. And the thing here is that then this Lambda function needs to respond using the AWS SDK with the task token, send the task that was successful or was a failure. And here we have a little bit of coupling between the Lambda function and the state machine. We don't need to know about the state machine per se, so that's good. But yeah, we need to know that this work came from a state machine. You will see it in the code in a second. Then the next step after this work is done is that our state machine will check if the response was successful or not, because we will have the response from the asynchronous task that in this case Lambda did. And if the response was successful, it will send us an email that the response was successful. If not, it will send us an email that the response was not successful. So that's good. So let's go to the code and see this in action. Let me show you first the state machine. So I'm here in the state machine, and let's open the studio workflow. And here you can see exactly the same thing I showed you before. We have the first step is to put a message into the queue. And you can see here that it says that we are waiting for a callback. So in this case, this will make the definition to look something like this. I will show you the code. This is all implemented as infrastructure as code, and the code is available in GitHub, so don't panic. So here we have this wait for task token. And then we are sending some meters in our message. We are sending the task token, and this comes from the context of the state machine. So each state machine has a one task token that if you're using it multiple times, you will always see the same. And here we have just the payload that I'm passing the input of the state machine. Something very simple. Then when this finish, we are going to check the response status. And if the result is 200, then we move to a success. If not, then we move to send an error. And this is just sending an error to a topic in SNS that will tell me that the call failed or not. This is something, I don't know, I will not need it for the demo, but just to make it more complete. So how the code looks, we have it here in the template YAML. We start by defining the different parts of our application. So the first thing is our state machine. And here you have the definition. So this is the state machine definition. And you can see that there is some steps that I show you. The interesting one is the first one, that is invoking that sending a message to the queue. I show you already that we send a message .wait for task token, and we pass this. So this is something I sent. And then we have some timeouts here. Then if we go back to the template, we can see that we have a couple of definition substitutions. The queue that is defined here, task token queue, where we are going to put the messages of requesting this. And then the topics where we want the SNS, the notifications to come. This comes from my email. Yeah. And then we need to give permissions, and to the queue, we just need to give permissions to put a message, and then give permissions to put elements in the topic. So this is very simple. And then here we have the Lambda function that does some work. I will show it to you in a second. And basically it needs to have permissions to use the AWS SDK to send a task success or a task failure to this state machine. You could give an asterisk here because the state machine, you are not really defining it when you're sending these results, but I like to keep my permissions as tight as possible. And this is a trigger with the event in the queue. So let's look at the Lambda function, and we are using the AWS SDK version 3. And here we are basically getting the body. Depending if the body, its payload has a success, we are sending a task token, a task success command. And you can see here that the message of this command is just the output and the task token. We don't need to find the ID of the execution, the state machine or anything like that. Just with the task token is enough for AWS to know which state machine it needs to send this to. And the same happens with the failure. So if we don't have a success in the payload, then we have a failure. And again, we make a new message and we send the task token so it knows to where to send it. And then we send some errors and boom. And we use this client, the function client, and we send the command that we just created. So it's very simple. So let's see this in action. Let's start the execution. And for the execution input, you need to pass something like this for this to work. This is in the README file of the GitHub repo. Let's start the execution. This will put the message in SQS, invoke the Lambda function, and then because we are succeeding, it will just send me a notification that everything is good and that we can move forward. That's good. Then if we start a new execution and it says fail, we can do this, and then this will go check the response status and fail. So you can see the output here is exactly what our Lambda function was passing. So we can see the success, we pass a 200, and in fail, we pass failure. That's good. Here we pass failure and failure, and in the previous scenario, because it was a success, we have the 200. So yeah, that's how you do it. This was the video for me today. I hope you like it, and some more videos are coming for step functions, more specific demos and codes and architecture designs and things like that. So if you're interested in that type of content, don't forget to subscribe, turn on notifications and things like that. And the code is available for you to check in GitHub, so go ahead and find the link in the description box. And please, if you like this type of videos, don't forget to give a thumbs up. And if you want to learn more about the integration patterns, the introduction and other integration patterns, I leave you the introduction video here. And in this playlist, you can find everything about step functions. So I'm going to go in very deep into step functions. It's like a whole course for free, and you can find it in the playlist. So I see you in another episode of FooBar.